All right. Thank you for coming back. For anyone who's here live and anyone who's watching on the replay, this should be quick. I want to do 3 videos. They're pretty quick videos because I knew the last part was going to be long. So let me see. Let me get the videos going. So thank you for anyone. Someone just showed up, so I'm going to repeat what I said. Thank you for coming back. I'm going to show the 3 videos. I'm going to try to make it quick so that you could go on with your life. Random talk 3. Okay. So the first video is going to be, let me keep writing featured video. The first video is going to be on the audio spotlight. So let me get that going. Here is the title. These are not the 3 videos that I'm going to put on the course. After I get off of this, I'm going to make a playlist with the course, and then I'm going to list the videos on. So you're not, because those videos that I was talking to you about, they're half an hour long. And so that's like another extra hour and a half, and I don't think you want to do that. So here's the first video. Let's see. Oh, I don't have a window up. All right, let me play the first video. Oh, it's not fun. Let's see. All right. It's interesting too. I don't know what that was. Okay, this thing needs to get it together because it's kind of like slowing and rebooting and stuff. So I want to have like a steady video. All right.
Okay, everybody knows what this is.
Acoustic laser.
Laser,
He's showing
right?
acoustic
Nice
laser.
Beam of light in many applications. Have you ever, what about sound? Can we create a laser-like or a beam of sound? Well, it's very hard to do. And the reason it's hard to do is that typical sound wavelengths are like this big. And long wavelengths bend. They bend around objects. If you have 2 people on either side of a barrier here, an opaque barrier, they can't see each other, but they can hear each other, right? How can that happen? Well, the sound diffracts, and it diffracts because the wavelength's long. When the wavelength's small, if the wavelength was very small, the sound would just go out here, this person wouldn't hear. So this makes it really hard to create a beam. But people have been extremely clever about this, and there is a way. It's complicated. We teach it in an advanced course here, and it takes 2 lectures. Is that right, Andres? Well, he left. He's supposed to do that? Yeah, so I'm going to try to give you just the basic, make this really simple. This is called an audio spotlight, and it's only $2,000. And you know who paid for it? Your parents, right? Okay, so what it does is, it has some transducers here, some discs that generate sound, and it puts out 65,000 hertz, 65 kilohertz. How high can we hear? 2,000. Around 20,000. Well, you might be able to. Not you get older. Down around.
I don't think even them can hear. I don't think.
Yeah, I think. Yeah.
By now they are probably 18 or 17,000.
Yeah. We should have hearing tested. It's important. It's important. So anyway, 65 kilohertz, way beyond ours. Dogs can't hear it. It turns out cats can. Okay, bats, no problem. They're typically, they go up to 100,000 hertz. All right. So we can't hear this. It's going. I haven't turned it on yet. When I do, it's going to blast out a 65 kilohertz beam. Because the wavelength is so small, it doesn't spread. Because 65 kilohertz has a wavelength like that. So it's going to be, in that sense, similar to a laser. It just comes right out as a beam. Now, how do we make that audible? Well, they put a modulation on top of the 65 kilohertz. There's a modulation. And now, here's the next thing I have to tell you. That 65 kilohertz is very high amplitude. It won't hurt you, we don't think. Okay? You certainly can't hear it, and we don't think it'll hurt you. And it's very high amplitude. And what happens when you have two sound waves like this, sound plus sound can create sound, but only at high amplitudes. At low amplitudes, sound waves just travel right through each other. You may be sort of familiar with this. But at high amplitudes, you can create sound. So what happens in this apparatus is the audio sound, the sound that you're going to hear, is actually created in the beam, not here. And because it's created in the beam, and if it stays in the beam, we have a beam of sound. So let me demonstrate this for you. Let me turn it on. And I'm going to find the piece of music that we like.
Yeah.
You may not like it.
The Eagles? Yes. You like the Eagles? Yes. Okay, good. Oh, we have a friendly audience this year.
Yeah. I think they're just saying that to make us feel better.
Right. All right.
What? It's worth the $2,000. It's not our money. Now, the sound that you're hearing is being created in this beam. It almost sounds like it's coming from your head. So let me try to scan the whole audience here so everybody gets to hear this. Absolutely remarkable. Pete, are you getting it? Let's try to, one more thing. Let's try to bounce it off the wall. Raise your hand if you can very clearly hear it. I'm going to try to bounce it off the wall. Look at where the hands are raised. Put your hands down. No, it's bouncing off the wall. This is a beam of sound.
Okay. So you should definitely watch that video. Let's see. So when you watch the video, notice how the students respond to hearing the sound. This is an example that the TI's This is an example that the TI's V2K or voice to skull claims aren't crazy. When a new technology is being developed, it is in existence and is tested way before it is introduced to the general public. It's uncertain how long researchers have been working on devices like the Audio Spotlight before it became available on the public market. I think you should watch these videos for yourself. So the next video is called Turning Sound into Laser. Okay, let's get that one going.
Writing's not that easy,
Okay.
but Grammarly can help. This sentence is grammatically correct.
Commercial. Ugh.
As you've probably been told, light and sound are both waves.
Okay, hold on. I'm gonna try to get steady.
Light waves can
I'm
be
going to
spread
play
out
that
like a
again.
light bulb or
Hold on.
focused like a laser. But can you do the same for sound?
Okay, let's just start that again because I hate when it breaks up like that.
As you've probably been told, light and sound are both waves. Light waves can be spread out like a light bulb or focused like a laser. But can you do the same for sound? Surprisingly, the answer is yes. And I'm going to show you how I built this device and how you could build your own. So normally when sound travels, it disperses and spreads out like you'd expect. But this is actually dependent on the frequency. The higher the frequency, the more focused the beam is. I don't know why the math works out this way, but I just accept it. But the big issue is that the frequencies needed to get sound focused are actually in the ultrasound range, so it's beyond the range of human hearing. But there's this really weird physics glitch. Okay, it's not a glitch, but it's a weird property where when the frequency and amplitude are high enough, the air itself becomes a nonlinear medium and is able to demodulate a modulated waveform. Yeah, it doesn't really make sense to me either, but I'll link the Wikipedia article. But anyway, that aside, it means we can encode audible sounds by modulating them with an ultrasound carrier wave. This is actually exactly the same as how FM radio works, only the ultrasound frequencies are in the kilohertz instead of megahertz. And since individual ultrasonic speakers are pretty small and not very loud, I actually have a bunch of them connected in parallel. Designing a circuit for this was pretty straightforward. The audio comes in here with a simple high-pass filter to get rid of DC offset. That signal travels to a standard 555 timer to modulate a 40 kHz square wave. Finally, it's fed into an amplifier to drive the speaker array. It's powered by a 12-volt power supply for the speakers with a 5-volt regulator for the logic parts. So how well does it work? Really well.
He's moving it away from the sound system. Now he's like in front of the sound system. Now he's moving away
It's so
from
hard
it.
to show in a video, though. You really have to be there to experience it. But I can at least describe what it's like. First thing to notice is that the sound travels pretty straight through the air, but as soon as it hits a surface, it demodulates and becomes audible. So if I point it at a wall, it really sounds like the sound is coming from the wall, not from the speaker. And as I rotate it, it sounds like the sound is crawling along the wall to the ceiling. If I point it at someone's head, they can tell it's coming from the speaker, but to another observer, it sounds like it's coming from that person. Pretty cool. But that means if you're trying to make only one person hear it, it has to be pretty quiet to eliminate reflected sound. Another interesting thing compared to normal speakers is that very small objects can completely block the sound. Just putting a piece of paper in front blocks it completely. Anyway, hope you learned something new. It was a really fun project to put together, and I'd encourage anyone who wants to make something similar to give it a shot. Minus some tuning, it wasn't as difficult as I thought it would be. Thanks for watching.
Okay, so that was quick and easy. So this was just to show that anyone with a basic training could put together their own kind of like audio spotlight. I mean, he got the article from Wikipedia. I use Wikipedia, but that's not like hard. That's not like a, a science, a real, well, yeah, it's not a real science article, and he got the information from there and put something together. So, and then the reason why I'm doing that is because remember I said before that I think the general public probably was able to put together their own like mind control technologies or something similar, even though it probably would not be on the scale of what the government or a research university could do. So, and that was going back to the factions or the little inner groups within the network, and who's responsible and who's doing this. I don't think there's one person. I don't think it's all government. I don't think it's all, Masons, Scientology, aliens, reptilians, who else gets the blame? Catholic Church, Christian Church, I don't know. Masons, I said Masons already. The Lodge Club, I don't know. There's so many people out there that TIs have said they found that they were associated with this, and they could be right. They could be right, because I think there's like certain groups, Satanists, there could be certain groups that are in this doing their own thing with the technology that they have received. I mean, if you think about psychopaths, I said before, I think in the first one, there's no honor among thieves, and a military veteran and a convert to the system said that to me. So I could totally see a psychopath being introduced to this technology, using it, and then doing their own thing with it, you know, within like the group and stuff. I could just totally see them doing that. And then like, they become someone trying to rise in power within the group because that's how psychopaths are, Psychopaths would love to control other psychopaths and psychopaths would love to control the general public. So that's why I think, and I could be wrong, that there's different groups in it and that each psychopath who learned how to do this probably formed their own group and stuff. And so whatever. And that could account for why some TI see it as this group, some TI see it as that group, some TI see it as, this thing. And there's no like there's no like one person that's involved or one person that TIs think are involved. But that said, let's go to the last video so that you can go to sleep with all your new knowledge. You're so like knowledgeable. You have like a basic understanding of electronic harassment and where it comes from now. And honestly, I think at this point, you could quote Delgado's book like a pro. Okay, maybe not like a pro, like you're like in his field or anything, but you could talk about it. You could create, like, you could talk about electronic harassment in a new way that, not in a new way, but, I think basically, I think, like, most of the TIs, I mean, most of the videos TIs have are anecdotal, or it's firsthand. I think it's very valuable that it's firsthand because TIs are sharing their experience. And then, of course, and I've given anecdotal examples also, but I also have given like hard facts and hard research. So now when you talk about it, you can give hard facts and hard research to kind of like support what you're saying. And that's why I thought it was very important to read the book, you know? And then you could also look into it like, what can you find? I showed you what I found that out there about this. So let's do the last video. I don't know why this is
For
so slow.
most
Oh my
people,
gosh, these
tapping into solar
commercials.
energy has meant installing
I can't stand them. I think that's why people watch YouTube in the first place, because they didn't want to see so many commercials. But whatever. All right. And I don't have the sound on because I was trying to not hear the commercial. Okay, here.
Have you ever wanted to spy on the people around you using just a beam of light? Well, with this old but nifty trick, I have just the solution for you. This episode of Scientific Tuesdays is brought to you by HostGator. Before we go into spying, we first need to figure out why the audio-driven laser apparatus actually works. So, let's give it a shot. Get a laser pointer, a solar panel, some mono audio jacks, a battery holder, and some wires. You can get them all at your electronics store and fairly cheap. And if you want to go even cheaper, get a $1.50 laser pointer at your local drugstore. For some bizarre reason, they actually sell them at the front counter. Okay, first I'm going to take my green laser pointer apart here. Now I'm using a green one just because I have one laying around and it's awesome. It's going to give me a nice bright light for the camera. So let's take a look inside. You see that little spring in there? First thing we need to do is hook a wire right up to it. Then take a second wire and hook it up to the base of the laser. We're going to build a very basic circuit that's going to help drive audio through the laser itself. Now, first thing we need to do is hook up the prong from the laser up to the negative port on our battery holder. That's the start of our circuit. Now we need to move on and hook the positive end up to the small prong on our audio input jack. We're also going to take a second wire and hook it up to the long prong. Here, take a look. Basically, we're going to drive power through to this so that we can add sound through the laser itself. How amazing. Okay, finalize the circuit to the battery holder, and we're ready to give this a test once we plug it into an MP3 player. I'll use my iPhone and load up a song, and as soon as I do that, the laser will turn right on. Now, one cool thing you might notice once you've got the music pumping is that if you point the laser at a surface, you'll see that it's gyrating. When we add an audio source to a laser circuit, basically what's going to happen is the laser itself is going to output a sound wave that we can capture with the receiver. We'll make that in just a second. Okay, now we need a way to receive the audio from the laser itself. We can do this very simply. All we need is this solar panel here, a couple wires. Go ahead and hook those up any way that you deem fit. When you're done with that, hook them straight up to the mono jack. And as I said earlier, you can get all of this at your electronics store for just a few bucks. Okay, we've got that ready. Now let's plug it into some speakers I have. You will notice a hum. That is the light source hitting the solar panel and causing an electrical interference. Now if I hit play on my iPod and then point the laser right at the solar panel, we start getting some sound. Yeah, it's really not that clear. Let's kill the light. Little bit better. You know, wheezing out the interference just a bit, but still not that great. However, if we were trying to spy on someone, we might be able to make out what they're saying if we listen long enough. Oh, right. And if you ever had aspirations to be a DJ, well, here's a new method. Try laser DJing. You can scratch just like the pros. And finally, the fun part, spying or eavesdropping, whatever you want to call it. Remember that little apparatus we made earlier with the laser? Well, disassemble it. We actually don't need it anymore. All I wanted to do is show you that you could actually stream music over a laser beam, but we don't need that. So, take your laser, hook it back up. Cool. I'm going to mount my solar panel right by my window and point it towards some others' windows. Then I'm going to hook it into my iPod so I can record it, and then aim the laser at some windows right here. Basically, the reverberations from the speech inside will reflect through the laser itself. They'll be captured in the receiver, and then we can hear whatever they're saying inside their rooms. Kind of creepy. Let's see what we get. Just keep in mind we need to bounce the laser off the window and back into our receiver, or no audio will be found.
Hello. Oh, hey, Sarah, what's going on? So I guess you were Ricky's out of town. Yeah. You want to come by and hang out? Which is what I was thinking. All right. See you in a bit. All right, man. Everything's coming over. You got me.
And just one more busted chump. I want to thank our sponsor this week, HostGator. I've been using HostGator for years now, and they can get your blog or website up and running in minutes. They've got plans that start at $4.95 a month, and you get 24/7 support, plus access to the website.
Anyway, so I was kind of skeptical about that video. I just don't think he actually achieved. I don't know. I just don't think he really. I don't. I don't know. I think he kind of like dramatized getting that sound from his neighbor's window, because it wasn't. And I thought I was the only one who was skeptical, but I read down in his comments and someone else was skeptical that he might have gotten that sound. The reason why I was skeptical was because when he was trying to do it with the his when he was trying to play the music with his when he did the first demonstration, you heard the music, but it was like really, really fuzzy. He was the panel was like right near the iPod. It was only like a few inches away from the iPod, and he couldn't even get a clear sound. But here he is blasting it from his window, and he got a better sound than he got. I'm not saying that he didn't do it. I'm just saying that I'm skeptical. But the reason why I showed you the video is because I think it's possible. So I think I think he did that. He did a quick video, and he posted results. You know, he showed that it was possible because he was able to get music from his iPod using the laser. But I think that someone who knows what they're doing and who knows more about sound acoustics, not necessarily an expert, could probably have gotten it to work with the window through the window. So the reason why I showed it was because I think that it is possible, if you just, and I think if he even just sat around and he tweaked it a bit, he probably could have gotten a better sound than that, and he probably could have achieved it. I'm not saying he didn't do it. I don't know. I'm just skeptical that he did do it through his neighbor's window. But I do think that if he knows about sound and how to do that sound engineering stuff, I think he probably could if he tweaked it. And the other reason why I'm skeptical is because I watched another video where a guy tried to do that and the audio wasn't that good either. So I mean, whatever, right? But I just wanted to show you that it is possible how much information is out there. People looking at Wikipedia. Some people will go to the science articles. Some people will look at patents. Some people will do the research articles. Some people will look on YouTube. And average everyday citizens could do their own thing. Not to mention that anyone who's recruited onto the Beast Network, Gang Stalking Network, they could also, after they learn the tricks of the trade, they could also deviate and do their own thing also. So it could be anyone. They could, see, like, they're so arrogant and disgusting, that they probably will be like, well, I'm not listening to this guy anymore. I'm going to do, me and my friends are going to get together and we're going to like form our own little crew and do our own little thing. So it's just like, it's probably a more dispersed problem than it appears to be, or humans want it to be. So with that said, I think that's all I had to say. 3 videos I showed you. Um, the book club is now complete. I hope you got something out of it. I don't know when the next free TI hour will be. I don't know when. I don't know what the next TI hour will be about, and I don't know when it will be. I'll post details when I do know. I want to thank you for watching, and that's pretty much it. Have a good night. Bye.